All right, let's work on this exercise where we need to merge two sorted lists. So what is a list in this context? So lists are comprised of list nodes, and the list node class is defined here. And so each list node has a value and a next node. And the value is just some numeric value, and then the next node refers to another list node. And so like when we see in this example here, we have list 1 is 1, 2, 4. This isn't really a list. At least in the context of this problem, list 1 is a list node. It is a head of a linked list. And so the way this works is that each circle here represents a different object from the list node class. And so this one here, this is a list node where the value is 1, and the next list node is this list node, which has value 2, and the next list node is this list node where the value is 4, and the next list node is none, because there is no node following this particular list node. And so therefore the next node is none. Okay, so we are given the heads of two sorted linked lists. So list 1 and list 2. So in this example here, where we have list 1 consists of nodes with these values, and list 2 is a linked list whose nodes have these values. List 1, it actually just refers to this particular node, and list 2 refers to this particular node. Okay, but given the heads of two sorted linked lists, we want to merge them into a single sorted list. And we basically do it by splicing the nodes together. And we want to return the head of the merged linked list. And so we can see here the way that this was combined here. So we started by default with list 2. We could have started with list 1. It doesn't really matter which one you start with. Basically, you start with one of them, and then you have to decide, okay, so now do we want to, should the next node come from list 1 or list 2? And at this point, I guess we're starting with list 2. So what we do is this list 2 node goes here. And then once we move that node to the beginning of this merged linked list, list 2, the head of list 2 becomes this value here, 3, because we've already used 1. Okay, so then after this node, we have to decide, okay, should the next node come from list 1 or list 2? And here it's, well, 1 is the strictly smaller value, and so it needs to come from here. So the next node, we're going to come from here. And so that's why that goes down here. And then after we move this node into the merged linked list, we update list 1 so that the head of list 1 is this node with the value 2. And so then we compare the two heads again. So now list 1 head is here, list 2 head is here, list 1 is still the smaller value, so we move that here. And then we continue in the same fashion. We're here, we could go, the list 1 head is now 4, or the list 2 head is 3, and 3 is smaller, so now we add that in. So now we're here, and now we have these two values, and it's the same value, so it doesn't matter which one we choose. So let's just go with the list 1 head, and so that's going to be here. Okay, so now we're here, and now at this point, we've moved all of the nodes from list 1 into the merged linked list. And so as we're keeping track of the head of list 1, the head of list 1 is now none because we've used all of the nodes from list 1. And so the only non-null linked list is list 2. And so we can just take anything remaining in list 2 and just add it to the end. And that's exactly what we do. In this particular example, the only value remaining is, the only node remaining has the value 4, so we just add that on. But we could imagine, let's say that list 2 had like 4, then 7, then 10, then 11, etc., etc. Let's say it had additional nodes. At this point, we could just take anything remaining in list 2 and just add it to the end, because there's nothing from list 1 to add to the merged linked list, and so everything else is going to have to come from list 2. And we know that list 2 is already sorted, so we don't need to worry about the order it's in. We can just take everything else and add it in there. Okay, so from this process, we can sort of see the logic for how we would write this algorithm. But I actually want to go through and you can skip over this if you are if you can see the pattern and can try to implement it yourself. But I want to do this in a way that's like very, very explicit, so that we can see like what the actual values are and how they change over time. Okay. I did this wrong. This should be a 3. Okay. Okay. And it actually bothers me a little bit that so here we started with node 1 by default. So here at the beginning, when list 1 and list 2 had the same value, we defaulted to list 2. But then when we got to this point and list 1 and list 2 had the same value, we defaulted to list 1. And that kind of bothers me, so I sort of want to default to list 1 at the very beginning. Okay. So what we're going to do is we're going to make this merged. Let me be able to smell this merged list. Okay. And so we start with list 1 and list 2. Actually, we don't even really need these, because list 1 and list 2 refer to particular nodes. They're the head nodes. Okay. So what we're going to do, and actually, I'm trying to think about the best way that I want to do this. Let's actually do everything here. 1, 2, 4, 1, 2, 4. We can make this a little bit bigger as a result. Okay, so we're going to start with list 1, and we want to make a merged linked list. So what I'm going to do is we need to have some sort of like current node that keeps track of where we are in the process of creating the merged linked list. So I'm going to refer to this as current now. And how did I choose this? Well, we need to initiate this process by choosing either list 1 or list 2, depending on which value is smaller. And since they're equal, let's just say from here on out, if list 1 is less than or equal to list 2, then we use list 1. So here, list 1 is less than or equal to list 2. In fact, it is equal, and so we'll set this to the current. Okay. So now, what do we want to do? So this node is going to be the current node in our merged linked list. And so then list 1 can move over, and it can start here instead. list 1. Okay, so we've moved list 1 over. Okay. And this node is still current. Okay, so now we need to figure out what node comes next after the current node. And we could either choose list 1 or list 2. And list 2 has a strictly smaller value. And so we're going to go with that. And so the next node after current is going to be this node. And this node will become our new, let's see here. Well, actually, let's see here. So this is going to be our next. And then list 2 can move over now to here. We can move list 1 down the line because we've already used this node from list 2. And so we no longer need it. So when considering adding the remaining nodes from list 2, we can move on to the next node because we've used this one already. Okay, so now this will become our new current node. Okay, and so now we need to figure out which one comes next. List 1 or list 2. List 1 is strictly smaller here, and so what we're going to do is we're going to link the current node to list 1. List 1 can move down the line because we just used the head of list 1. Okay, and this will now become our current node. Okay, now we need to figure out the next node. List 2 is strictly smaller, and so we will point to this node. Since this node has been used already, we can move the head of list 2 down because we just used the head. And this node here will become the current node. Okay, and now we have to figure out where to go from here. We could either go to list 1 or list 2. And they're equal, and so we said at the beginning that we're going to default to list 1 if they are equal. And so now we're going to point to this one. Okay, so we're pointing here, and then list 1, we're going to update list 1 to be whatever comes next in the list after this node. Whatever comes next in the sorted linked list with head list 1. And this was the end of the linked list. And so the next node was none. And so we'll just put list 1 up here and just indicate that it's like none. The value of list 1 is now none because we just used the final node in list 1. It is a little tricky. If you notice, I'm using list 1 to refer to both the head. Yeah, I'm being a little not precise in my vocabulary. Sometimes I use list 1 to refer to the head of list 1, and sometimes I use list 1 to refer to the entire sorted linked list with head list 1. So by the problem statement, list 1 should refer to the head of a sorted linked list and not the entire linked list itself. But it's a lot of words to say sorted linked list L1 or sorted linked list with head list 1. That phrase is really long, and I don't want to have to use that phrase every time I'm referring to the entire sorted linked list. And so that's why I've been using this sort of abusive notation, or I guess abusive language, this not precise language. And it should be clear by context whether I'm referring to the head or the entire sorted linked list. And that's the main reason why I've been using this imprecise language, is that the precision should be implied by the context. Okay, but now that we've taken that final node, we can move the current node down. And now at this point, we've completely exhausted list 1. And so anything remaining in list 2, we can just connect to this. And we can imagine if list 2, if this had like 5 and then 10 as well, Let's say this had a whole bunch of other stuff. It wouldn't matter. We would just take the rest of this and just add it on. And then this would be the end of our algorithm, because we would end up with this final merged linked list. And remember, what we said here is we want to return the head of the merged linked list. So this would have to be the head. Okay. And so the one other thing before we actually write the code, when we actually think about how we're going to implement the code, what we could do is we could have this, we could start by making a new node. And let's just say it's like the default value, if we go here, the default value is 0. So let's just say we have a default node or a default list node. And let's say it has the default value 0. And this will be our head. And we'll just point to this. And then this would be head.next. And we would figure out which one of these to link head to based on which one had the smaller value, or smaller than or equal value. And we went with list 1 first, and so that's why we're pointing here. Okay, so the point here, we need to return the head of the merged linked list. And the way that we can do that is at the very beginning, create a new, like a sort of a default, just a starting node, and then build off of there. And the next node after this would be the head of the merged linked list. And so when we're actually returning a list node at the end, we would return this one, which if we called this one head, this one would be head.next. And perhaps calling it head is a little bit confusing, because this says return the head of the merged linked list. So we could just call this node x, and then the head of the merged linked list would be x.next. Let me make this a little bit closer here. Okay, but the point here is that this is how we would go about making sure that we're keeping track of the head of the merged linked list. Okay, but now that we've talked through the logic here, let's actually implement it. Okay, so we're merging 2 linked lists, and we're going to start with head. Again, this might be a little bit confusing, but we're going to make this a list node, and we'll just give it the default values. And then remember, at the end, we're going to return head.next. The only reason we have this head here is that we're using it to keep track of, the only reason we have this is that the node that comes after head is going to be the head of the merged linked list. Okay, but this, oh, that's not what I meant to do. Okay, well, this is going to come at the end here, so let's delete it for now. Okay, so we're going to start with this head, and then remember, we're keeping track of the current node in as we're building the merged linked list. And so we're going to start at the head. And then we want to loop through the two linked lists. And sort of like loop through the heads and keep doing the process that we talked about until one of them runs out. And so when we're starting our loop and we want to figure out what the stopping criteria for our loop should be, well, like we said, we want to continue this process until one of the lists runs out of values or runs out of nodes. And so what we are going to do is we are going to make the condition while list 1 and list 2, meaning that this process continues so long as there are nodes in list 1 and list 2. Again, there I'm referring to the sorted linked lists, linked lists with heads L1, heads list 1 and list 2. Okay, but while these lists have nodes in them, we're going to look at list 1 and list 2 because these are the heads, and we want to see if which one has a smaller value. So if list 1 has a value which is less than or equal to list 2, then that list 1 node we want to make the next node in our merged linked list. And so if we remember how we did that, what did we have to do? We had to update, we had to update the next node after the current node to be the one that to be the new node. Then we need to move down that node, basically update the head of list 1 or list 2, whichever one was updated, to move down the list. And then the last thing would be to move the current node to that node that just came from one of the lists. Okay, so putting that in code, what we're doing is, so the next node, so if list 1 has a value which is less than or equal to the value of list 2, then the list 1 node is going to be the next node. And so current.next is going to be list 1. But now that we've used this node here, list 1, the head can point to the next node in the list. And so list 1, we're going to update it to refer to the next node within list 1. And then the final thing that we need to do is we need to update the current node to be the new node that we just pointed to. So here current would be equal to current.next, which is what was previously the head of list 1. Okay, but now it's just current.next. Okay, so this moves what we refer to as the current node. Okay. Otherwise, list 2 has a smaller value. So current.next will be list 2, and list 2, we will move down that list because we just used the head. And then again, we would update the current node. And I just wanted to write this out at the beginning here so that you can see the flow of the logic. But now we can see here that updating the current node is identical regardless of whether we updated the merged linked list to point, whether we updated it to include list 1 or list 2. And so instead of having this in each clause here, we can just do this so that it's, because the same code is run regardless of which value is greater. Okay, and so then that's pretty much it. Then after this, after this line is run, we're now pointing to a new node, and we can go through and evaluate which of the next which next node to include in the merged linked list. Okay, and so then we'll continue this process until this condition is no longer met. And what that will mean, if this condition is no longer met, then what that means is either list 1 is none or list 2 is none. And if list 1 or list 2 becomes none, let's just say without loss of generality that list 1 became none. So what that means is that we went into this clause where list 1 had the smaller value. So then the current node now refers to that final node in list 1. And then list 1 was updated to be list1.next, which is none. Because in this scenario we're considering, list 1 was the last node in the list, and so its value of next was none. Okay, so now list 1 is none, and that's why this will eventually get triggered. Then current will become current.next, and so current will refer to this final node in list 1, which has that value and which also has the value for next is none. Okay, so once we exit this loop, what that means is that the current node is either the final node in list 1 or the final node in list 2. And it is pointing to none, meaning that the value of next is none. And so we need to update the value of next to be whatever else might be in the other list that still has values in it. And so we need to update current.next to be, well, if list 1 still has values, then it should just point to list 1, because again, list 1 is referring to the head of list 1. And then just by pointing it there, it will include anything else remaining in list 1. Otherwise, it will point to list 2. Okay, so if there are values in list 1, it will point to list 1. Okay, and how can we determine if there are values in list 1? Well, we exited this loop because between list 1 and list 2, one of them became none. And so whichever of the two is not none becomes the value of current.next. So current.next will be list 1 if list 1 is not none. And another way to write that is we could just write if list 1. Otherwise, if list 1 is not none, so it will be list 1 if list 1, meaning that like if there are still nodes remaining in list 1, or if list 1, to be more precise, if list 1 is referring to an actual node, then that node will come after the current node. And then it will also include anything else remaining in list 1. Okay. Otherwise, list 1 must be empty, and so then we just include anything else at the end of list 2 here. All right, and so and so once we've done this, list 1 and list 2 will both be none, and all of the nodes that were originally in the sorted linked lists, list 1 and list 2, will have been added to the merge linked list, and so we're done. And so we're going to return, and again, what are we going to return? So we made this head here just to start the process. But the actual first node in the merge linked list is whatever came after the head. And so it's going to be head.next. Okay, and let me just make sure I didn't include any bugs. There is a bug here. I thought I had that in there. That's very weird. Anyways. Okay, and so let's just submit just to be sure. Okay, and yeah, so that's how we do this process. So, or that's how we solve this exercise. And so this is a good introductory exercise for these exercises involving sorted linked lists and list nodes, and just to get you used to working with these with this particular class. But in any case, that's all we need for this exercise, and so we are done.